Hey guys, so I'm back with another tutorial. It's been a while, but I'll try to be more active from now on. The tutorial that I have worked on this time is actually this effect that you see on your screen right now, where you sort of peel this blue film effect off of a metal platform. And this was obviously made in Houdini. I'll just play the screen blast in front of you so you guys can see. And there you go. It's actually a bit longer than that, but I'll just take you guys through it really quickly. So this is the node tree. Obviously, the scene file will be included. So the way that I made this was I started off with a basic grid, and it was actually pretty dense. So this might end up cooking up your machine, but good thing Houdini actually handles this pretty well. Added a standard UV texture on top of it, so we got UVs. Uh, After that, I actually used an attribute from map, and there was this displacement map that I got from Grayscale Gorilla. Shout out to them. Those guys make some amazing maps. I had this displacement map, and this whole thing was actually a workflow that I found on YouTube. I will link this in the description, the tutorial in the description, and through that, I was actually able to displace my whole grid exactly according to how the displacement map showed it. Now, once that was done, I got some artifacts, some weird things going on around the edges, and um, uh, a very high poly mesh, which obviously wasn't suitable for me to simulate. And also because we're doing this with Vellum, Vellum does not usually work well with quads, so I had to somewhere convert this into tries, but we'll come to that. Uh, Next thing, what I did was I just created a group node to select the boundary, and I just selected this to edges and turned on include by edges, enable, and unshared edges, which enabled me to select the boundary for the actual mesh. Uh, After that, what I did was I actually deleted that group, and just give me a second. I used a poly reduce to sort of, just reduce the number of polygons for the whole mesh and to clean the mesh up a little bit. And once that was done, I actually did the exact same thing all over again with the boundary selected, right? But this time for the low poly mesh, and I just use a transform to sort of scale the edges of the mesh down so you could see um, how the edges that were previously looking something like this have now sort of just transformed down to form a uniform edge. Uh, After that, it was pretty much standard polyfilling the whole mesh to make it look solid. And after that, I just added a group node in which I selected. This was set to primitives, and I just selected all the primitives inside of this mesh. Now, this was actually just for this was actually the preparation for the collider of the film, the collider that we're going to use for the film to collide with, and obviously to stick with. Now, if we come back to the part where we're working on the film, what I ended up doing was, so if I just turn this unshared edges on, you'll see this is where the initial geometry was. And what I ended up doing was I ended up sort of just using a transform to just give it some offset so that it does not intersect with the collider geometry. And after that, what I did was and this is actually important, I just promoted the group that I created over here, which was edges, unshared edges. I promoted those unshared edges groups from edges to primitives. And what that did was it selected all the primitives that were along the boundary line. And this was important because over here, this was sort of self-intersecting itself, and if I just went through with this, it gave me some janky outputs. So what I ended up doing was I used that group promote and followed on with a group expand, right? And just expanded on that group and just deleted the outer edges, right? So whatever I was left with had no intersections and basically just removing the outer slice for the whole film. And once that was done, I did the exact same thing and I reduced the number of polygon counts over here just to, make my workflow a little easier. Because I mean, this was definitely like slowing down the whole process. And once that was done, I remeshed the whole um, top to a triangle geometry. And as I told you guys earlier, this works better with Vellum, right? Once that was done, what I did was, I'll just skip these two parts right now. What I did was I just used a group node, right? And this was set to keep in bounding boxes, and just selected a couple of points around the edges and used a transform node. Gave it that transform points group, and just animated it by hand to sort of move in a certain direction, right? There you go. You can see it looks awful right now, but bear with me. Right. Once that was done, I added a vellum cloth constraint, right? And obviously that vellum cloth constraint that was set to cloth, and this is basically just a Houdini. There you go, this one. There's just a basic Houdini template and it sets up everything for you. And I used my collision geometry as the collider over here, right? Once that was sorted, wait, let me just turn that off. Uh, Once that was sorted, what I did after that was I added a vellum pin constraint, and what this did was it actually so you remember the transform points group that I used? I used the exact same group over here, and what this did was it actually used these number of points as a controller for the whole animation, right? So this way you can actually tell Houdini or tell Vellum that these number of points are going to sort of drive the whole simulation, right? And I use the pin to animation tab to set the pin to soft and the orientation pin type to soft as well. What the soft does is that it sort of blends between the animation and the simulation. So if you're using forces and something like that, the animation is sort of going to be affected by that. I think everything else was pretty much standard. I didn't meddle with other things over here, but with the cloth settings, I did actually fiddle with the stiffness and the bend stiffness and the damping ratio over here. Those are the things that I actually, meddled with. Now, coming to the crux of this whole simulation, and that is vellum attach. Now, I know there are a lot of tutorials that say that we can also use vellum glue, but I think that only works with dynamic geometry, whereas over here the geometry that I had was actually a collider and not something which was dynamic. I mean, I know I could have used vellum shape match constraints and gave it a floor, and just that would have worked as well, but it worked like this for me. Now, in vellum attached geometry, what I ended up doing was these were my settings for the stretch, and yeah, and also I had to give it a target geometry. And remember this group that I made over here, which had all the primitives for the collider, I gave the exact same group over here, which told Vellum to attach my cloth, or in this case this film, to that certain collider. And you can see that it creates these little balls which actually show all of the points that this geometry is being connected to the collider down there. And once that was done, there was actually one small thing that I didn't talk about, and that is this breaking. Now, what this does is it actually tells Houdini how far to stretch the cloth or how far to stretch the film before the glue or the attached constraint actually breaks, right? And this is done via a threshold, and you can use stretch stress, stretch distance, or stretch ratio. Another thing that I use to actually add some variation over here is I use a scale by attribute, and this creates a break threshold scale, right? And what I did over here was I actually created an attribute noise, and let me just open this up for you. I created an attribute noise, right? And with that attribute noise, these were, by the way, this is a float, and these were my settings for the attribute noise. And I named the attribute as break threshold scale. So what this does is it tells Houdini over here that this part is actually higher in value. So this is going to have a higher break threshold scale, right? As compared to this part. So it adds a little more variation to it. Another thing that I actually did was I'm pretty sure you guys have seen this with films and everything that there are air bubbles in there actually. Like it's not all flat and it's not all perfect. So what I ended up doing was I ended up using this break threshold scale or this attribute that I created and plugging this into a point warp. Right, I'll just open this point warp up really quickly. And what I did was so I used a simple vector to float, right? And converted my p values to float values. And I imported through a bind node, I imported my break threshold scale. I used a ramp node, right? And I added that value to the current value for p, right? And I converted that back into float to vector, right? And over here, what I did was I actually inverted the break threshold scale, and I'll tell you why I did that. So, but before we get to that, you'll see that it creates these little lumps over here, right? The way it creates these little lumps over here that actually sort of and I'll just show you. There you go. It creates these little lumps along the film that sort of just mimic the way that that film is inflated or mimic the way that there's air inside of it. And the reason why I inverted the break threshold scale was so if you think about it realistically, if there's air inside of this lump over here, right? The glue underneath this isn't going to be as strong as let's say over here, right? So this part, which was actually inflated using the break threshold scale. My God, that's a tongue twister. Uh, this part, which was created using that scale, is actually going to have the least amount of resistance when it's being detached. Does that make sense? So if I just turn the break threshold scale on now over here, you see this part is actually where the threshold scale should be the lowest, right? And that is exactly why I used a fit range over here to invert those values. And if I just come over here, wait, what did I export? Oops, sorry. Let me just really quickly copy and paste this. There you go. There you go. So you see, now it's inverted. Now, once all of this was settled and all of this was done, I just cached it out. And let me just turn this scale off. And oh, by the way, my Vellum solver settings, I had nothing inside of here, just so you guys can see. Uh, okay, why did this stop? Sorry for that. Okay, now if you come into my Vellum solver settings, I had my substeps all the way up to 4 and smoothing iterations all the way up to 100, right? I cached this out, and the simulation that I got was looking something like this, right? And this looked good to me. And obviously, the values that I used were I came up with them through a couple of iterations. Now, after I did that, what I actually wanted to do was I this edge was looking really, really janky to me, right? And I wanted to sort of smooth it up a little bit. So what I ended up doing was I ended up using a colored attribute, right, to give it to the original mesh, and I transferred that color attribute to my simulated cloth. And what that did was it created this sort of a mask, as you would say, which sort of separates, excuse me for that, separates the areas between the part that is at rest and the part that is being stretched. And after that, I used an attribute blur to sort of, blur that seam, and I converted that mask into a group of points through a simple group expression, and just smoothed that certain group out. And what that did was it just smoothed the faces of that edge, and now it's not as harsh, and I just deleted the attribute delete from them. Now I know I could have just smoothed the whole area out as well, but what that did was it sort of got rid, or it sort of just smoothed out these wrinkles over here as well, and I really like these, right? And after that I just subdivided this one time and applied normals and exported my alembic, right? And that is exactly how I ended up um, with this simulation. Now, if you guys are interested, I can actually put up some images for you guys to the render that I did, and there you go. This is how it came out. This was rendered out in Cinema 4D and Octane, and there you go. And yeah, so I guess I will see you guys in the next tutorial then. All right, cheers. Bye bye.